Hello everyone. Today let's discuss a topic of great interest in the engineering field, the domestic substitution of imported IMUs. How exactly should this be done? Many people believe that domestic substitution simply involves swapping out a sensor. In reality, however, a successful IMU replacement project entails a comprehensive process that includes requirements analysis, hardware adaptation, software porting, calibration and validation, and mass production implementation. First, the initial step is the breakdown of requirements and risk assessment. Before proceeding with a replacement, one cannot simply select a model. Instead, it is necessary to conduct an in-depth analysis of the technical specifications of the original imported IMU and establish a comprehensive parameter comparison table. Key parameters include gyroscope bias stability, angular random walk, scale factor error, accelerometer performance, measurement range, bandwidth, and temperature drift characteristics. Next, we must verify the hardware specifications, including dimensions, mounting holes, voltage, power consumption, and pinout, alongside protocols like SPI, I2C, and RS485. If these match, a seamless drop-in replacement is possible. Based on these parameters, the difficulty of replacement can be determined. If dimensions, interfaces, and performance are identical, a direct drop-in replacement is possible. If temperature drift or algorithmic discrepancies exist, compensation and software optimization are required. If the discrepancy is significant, the hardware and algorithms will need to be redesigned. The second step involves IMU selection and performance benchmarking. Several domestic products are currently approaching leading international models in key performance metrics such as bias stability, random walk, and full temperature performance. When selecting a product, 6 aspects must be comprehensively considered: performance matching, hardware compatibility, protocol adaptability, environmental reliability, supply chain costs, and technical support. Third, we address hardware compatibility and circuit modifications. Ideally, a 1-1 in situ replacement can be achieved. If the dimensions or pinouts differ, interface mapping can be achieved using an adapter board, thereby avoiding extensive modifications to the overall system structure. At the same time, attention must be paid to power supply capability, signal levels, filter design, and vibration damping structures to ensure the stable operation of domestically produced IMUs in real-world environments. The fourth step involves porting software drivers and adapting protocols. Software replacement is typically a critical phase of the project. It requires reconfiguring low-level communications, register parameters, sampling rates, filtering settings, and data formats. At the same time, attitude algorithms and error models must be adjusted to ensure the domestic IMU aligns with the original system's data processing workflow. The fifth step is full temperature calibration and error compensation. Due to manufacturing variations, each MEMS sensor exhibits unique bias and temperature characteristics. Therefore, a high-quality replacement must incorporate a comprehensive temperature compensation and automatic calibration system. Conducting full temperature testing can reduce the impact of temperature drift and improve long-term stability. Finally, there are reliability verification and mass production. Replacement products must undergo static testing, dynamic turntable testing, temperature cycling, vibration, shock, and long-duration operation testing. Only by demonstrating stable performance across various complex environments can it proceed to small batch, pilot production, and final mass production. In summary, replacing imported IMUs with domestic alternatives is not just swapping a part. It is a comprehensive system engineering process. It involves requirements analysis, model selection, hardware adaptation, software porting, precision calibration, reliability verification, and finalizing the design for mass production. By advancing through the complete process, domestically produced IMUs can fully achieve performance parity, cost optimization, and supply chain autonomy and control in application scenarios such as industrial grade and tactical grade use.